Hey everyone, how we doing? Let's continue on here in Algebra 2. We're in section 2.5, talking about linear models. Okay? A lot of application to what we do in here in math to real world stuff, and this is a way of showing it. Whether you're looking at the stock market, price of homes, there's all kinds of things that you can compare in life, that you can graph, that you can then come up with an equation and then use that and extrapolate it and predict things in the future. The way we do that is with scatter plots. And you can see here, what's a scatter plot? It's a graph that relates two sets of data by plotting as ordered pairs. Okay? And this is how we tie in the real world here. A couple of things before we get into that. When you're looking at a scatter plot, it looks like this. It's where you got an XY graph and you're plotting points. Now this could be comparing the cost of homes versus a period of time, number of years. It could be the price of cars over a number of years. It could be how fast the winning time in the 100 has been in the Olympics since it started. So it could be the times that you're running versus the time in years that each Olympics happened. All kinds of things. You can pick up an almanac and find any kind of thing that you're comparing and graph it. Now if you get a graph and the lines do this, we start looking at correlations. Okay, what's happening here? What's the trend? And the trends kind of follow along in like we think about slope. You can see here over a period of time this is dropping. Okay, that's a negative correlation because if you ran a line through that, it'd have a negative slope. It's going down to the right. When you have points just all over the place, there's no correlation here. There's no real line that you could write or draw in here that would show you any kind of tendency. If you got something going here where the points are kind of clustered close together and they're going up as you go to the right, that's a positive correlation. Okay? Because if you drew a line through here, that's a positive slope. It's rising to the right. The closer your points are, the stronger the correlation. The more they're spread out, the less the correlation, to where you get just scattered all over and there's no correlation whatsoever. That's kind of like what we look like in our scatter plots. Let's look at an example here. If you take your book, problem 2 on page 105, I went ahead, they gave you a table, and I went ahead and plotted the points here. We're looking at the price in thousands for homes over a period of time since 1940. So the 0 year represents 1940. 10 years later, that's 1950, 60, 70, and so on. Okay? These are the prices here in thousands of dollars. So that's $20,000, $40,000, all the way up to 120. Now what I did is, in 1940, they said the price of a home was a little bit more than $20,000. So I put a point there. In 1950, it was almost $40,000. And then I just plotted the points that they gave me in the table. Okay? And you'll notice there's not a straight line that connects those. Okay, but it does have a kind of a positive correlation here. So what we do is we draw a line, a straight line through, and we call it a trend line or a line of best fit. It's like an approximation. The closer the correlation, the better our line will be. And they do this with stock market things. They can look at the prices of closing each day and whatnot, and you'll see a lot of that's kind of jagged. Looks like a mountaintop, but it's stuff like that people take and try to predict later on. You notice I got an arrow here. So you can keep carrying this out. This is your 2000 right here. You could keep going out, carry your line out, and take a look at what you think will happen in the future. Okay? But as far as this line goes, I've got 2 points here that I drew my line through. Okay? And as long as I know 2 points in the line, I can come up with an equation. We've been doing that already. We've been finding slope. We've been finding the equation, whether we use point slope or point intercept or slope intercept form. So here's my scatter plot. Here's my line of best fit or my trend line. Let me find an equation of this so that I can predict what's going to happen in the future. So we do that by finding slope first. Remember, when you find the equation of a line, you got to know slope. We'd like to know y-intercept. So we find our slope using our 2 points. Then we're going to plug it into, you can plug it in either one. Since we've been using this point slope here a lot, I used it. The y minus y1 equals m times x minus x1. We use that a bunch here lately. Then we're just going to take that equation and put it into the y equals form, like we did in the worksheet the other day. So here's my 2 points. Here's my slope. I got 1.6. Now, somebody else could take this same data and have a slightly different line through here. It's going to have a positive correlation, but it could be slightly different. Their slope will be very close to ours. Remember, this is an approximation. So we've got a slope of 1.6. I plugged in my slope. I took my x1, y1, plugged them in. Then I distributed. I added the 40 over, and there's my equation in slope-intercept form. So 24, that's about where I'm hitting right there, so it fits in pretty good. And there's my slope of 1.6. Now, the next question in this, now that we've got an equation, is, well, what's going to happen in 2020? Based on the way the trend's been going, what do we think is going to happen in the year 2020? Well, 2020 is 80 years after 1940. So I plug in 80 for my x into my equation, and I get 152,000. So following this trend right here, in the year 2020, that house, or the average housing prices at that time, should be 152,000. Will it be? Who knows? When you look what happened over the last couple of years here with the economy, a few years back we had a big boom. Housing prices were way up. Now they're way down because of economic things. But we look at trends, okay? And again, it's an estimation. So scatter plots, one example of how it's used. We'll look at a couple of different things in class about how we can compare two different things, two different units, and how we can come up with a trend line and an equation for that and extrapolate it for information into the future. Okay? There's another example in the book. Feel free to look in there in section 2.5. Like I said, when we get back into class, we're going to take a look at some of this application. This is some good stuff because you see graphs like this in the newspaper and magazines. You see them all over the place because it's a lot easier to interpret data looking at this than just a bunch of numbers. Okay? So hopefully this has been helpful. We'll talk more about it in class. We'll see you then.